Okay, there we go.
Yeah.
Well, I'd like to introduce you all to Cory Overton this evening. And Cory Overton is with the USGS, U.S. Geological Survey, and he's a wildlife biologist with them. And Cory, I think you've been doing this for 25 years, is that right?
Yep.
All right, congratulations. And
Thanks.
he's based in the Dixon field office. Now, I'm not too sure where Dixon is, but I believe it's to the south of us near Sacramento. Am I in the right ballpark?
Yeah, yeah, it's a little nothing burg between Sacramento and San Francisco, right
Oh,
on
all
the
right. I'll have to look that up on the map. And he's involved in a study of the the Great Basin lakes, such as the Great Salt Lake, make sure I say this right, and others of other saline lakes, and studying the effects of the hydrology of those lakes and the environment on the birds that breed there. And I believe tonight we're going to hear some about avocets and phalaropes, which I don't know much about, so I'm very excited about that. Cory said he does welcome questions during his presentation. If you would like to get any details about what he's asking about, or have him explain anything else, anything more in more detail, please let Cory know. And thank you. I'll let you get started.
Perfect. I will share my screen and everybody can see that?
Yep.
Yes.
Okay. So the talk that I prepared today is going to include the Great Basin stuff, but it's also going to include kind of the history, which is kind of part of the main part of the reason why we're doing our group in particular is doing work in the Great Basin. Dixon is not part of the Great Basin. It's a several-hour drive just to get there, and of course, the Great Basin is a huge place. So, but we were pretty well positioned in the USGS to provide some information towards this big effort that was really one of the few points of bipartisanship we've had in the last several years out of Congress. This is a congressional effort that dictated that the USGS should work with the Fish and Wildlife Service to provide information about terminal lake basins, saline lakes in throughout the Great Basin. And the language, a lot of the language for the legislation that got passed last year was written by the National Audubon Society. So there's a very strong and clear effort to include migratory birds, migratory bird habitat, and the recognition that in the Great Basin, none of these spots are an island. They're all interconnected in different ways for different species. So I'll get to that a little bit. I just wanted to kind of start off to saying, like Tricia said, I've worked for the USGS here in California for 25 years. Before that, I also worked for the USGS, but back then I was tracking mice and tracking and trapping mice. And so that doesn't really count. They didn't have feathers. So I don't consider my career started until I started catching ducks, which is what I did when I first came to California 25 years ago. I've worked on a whole bunch of different things since then. Pigeons, Ridgway's rail in San Francisco Bay, snakes, but it's really nice to be back working with waterfowl and waterbirds. Our main program right now is kind of built around this topic called AIMS for Wildlife. Which is an acronym. It's Automated Interactive Monitoring System for Wildlife. And this is really born out of the fact that things that used to be really uncommon 5-10 years ago are now very commonplace when it comes to wildlife research. And that's really the GPS tracking technologies that we have. And a lot of this stuff is still being implemented in kind of sort of one-off things, grad student projects, maybe a state-funded effort that'll work for a little bit. And all of these little things have their own, these projects have their own specific questions that they want to ask, but that data can be used to answer a lot more questions in a lot more areas, especially since these birds often move outside of target research areas or stuff like that. And that's really what AIMS is trying to do, is it's trying to collate this information and deliver it to folks that have a need for it. So a big part of our effort now is on building this out and finding the right people to provide data, the right people to use the data that we have. And we have a whole bunch of funders that have helped us kind of get to the point on this too. Fish and Wildlife Service and state agencies and NGOs in California, but also international. So we've worked with folks in Alaska and in Canada to mark birds up in the breeding areas that we know are going to end up coming down to California as well. So although I'm the one talking, there's dozens and dozens of people that have gone into getting us to where we're at. Our program started as the SMWP, the Sassoon Marsh Waterfowl Project, which was us and one other guy in our office sitting around trying to figure out how to provide information to landowners and regional government bodies that manage the Sassoon Marsh in California, which is it's technically the largest contiguous estuarine marsh in the West Coast. It's a brackish water marsh that sits right between San Francisco Bay and the Sacramento-San Joaquin Delta. So it's a very unique area. It's never been developed. It's never been farmed. The water's always been too salty to really grow much. And for the last about 80 years, it's really been managed as a series of duck clubs and a few big parcels of state wildlife area. And these clubs are one of the few spots in California where you have really intensive habitat management specifically for waterfowl. And with the 160 landowners that are in that area, there's a lot of variability in what people are doing. And we're trying to figure out what works best, what needs to stay, what needs to change. And that's really where we got started and why we started using these GPS trackers. And that's really led into what's now this current effort with the Saline Lakes. It's called the Saline Lakes IWAS, which is Integrated Water Availability Assessment. That IWAS term is something specific to the USGS. It's a large-scale water accounting effort. And there's several different versions of that around the country that have been rolled out over the last several years, including Chesapeake Bay, Willamette Valley, the Colorado River, a couple other spots. The one in the Great Basin is a little bit unique because the legislation that kind of authorized this had this migratory bird component. Most of the IWASs are really focused almost exclusively on water quality, water availability, and not as much on the ecological uses and needs of that water. Not that that's ignored, it's just not usually specifically called out. And it was in this language. And so because the recognition that the Great Basin is such an important spot for migratory birds in particular, our office was asked to come in and join because we had this long history in the region with tracking birds, and we already had a quite extensive amount of data to be able to leverage to understanding how these systems work, what they provide to species, and how that might change in the future. So the IWAS, you can find this on the web. It's not too hard to get into, but the sort of guiding principles about this is that there's sort of a sequence of cause and effects that get to how the Great Basin functions for migratory birds, and it really starts with water availability. Everybody knows if you have drought, you have worse conditions for water birds. If you don't have water, you don't have very many waterbirds, kind of what it boils down to. But water availability feeds into water quality. And water quality feeds into different habitats, and habitats feed into different uses for different birds. We have species that are specialists in hypersaline environments like Lake Abert, Mono Lake, Great Salt Lake. We also have species that are just as reliant on the Great Basin, but they're really focused on the freshest water sources that are in there, like pelicans. And so understanding the variety of species that are reliant in this system, and the connection between the different patches of habitat, and understanding on top of that how water quality and water quantity influence things like food resources or vegetation or other habitat characteristics is really what the goal of the IWAS is. The legislation that authorized this said that it could be funded up to $5 million a year. There's a lot of folks that still think we get that, but unfortunately we have been nowhere near that. We've been about a quarter of that funding. So I would argue that even at $5 million a year, this is a big ask. Most IWASs don't have to deal with birds and have to deal with one hydrology. It might be a big one. Chesapeake Bay is a big, complicated place, but there's one set of conditions. Whereas in the Great Basin, every spot is a little bit different. And the hydrology is all very, very localized, and it's hard to extrapolate from one basin to another. So a little bit about the work that led us into working with the saline lakes. We started in Sassoon Marsh, and we really started with sort of the needs, what we consider the big three. Most of my office has worked with waterfowl for, about 80 years. We were originally a field station of the Northern Prairie Fish and Wildlife Service office. And so we really were focused on mallards, pintail, and gadwall as the three primary species that are harvested in California. And the three species that were large enough to take the tags when we started. But what we realized pretty quickly was these devices were getting smaller and smaller, which were enabling us to mark species that have different sort of ecologies and behaviors. So we were able to bring in things like shovelers and widgeon, and eventually even some of the teal species like cinnamons and greenwings. Then at one point, what we've realized here locally in the Central Valley is that we have this sort of tension. We have an increasing goose population, particularly white geese, and they eat a lot of the same things that ducks eat. And geese are becoming super abundant. They have been for years. And so we have this sort of tension, this competition, potential competition between geese and ducks. So we started marking a lot of geese, and we've done pretty much everything except for Canada geese over the last several years. We rounded out with a few of the oddballs. We have a Eurasian widgeon pair that we marked a couple of years ago, and we have a really nice localized population of blue-winged teal. Localized, they're still migrating blue-winged teal, but they're very, very philopatric to one spot, so we can get these birds pretty regularly year after year if we want it. And then as part of the saline lake stuff and broader questions about drought and conservation planning in the Central Valley, we've started bringing in some other species. So you can, it's no longer just waterfowl. We're cooperating with Fish and Wildlife Service on a large white-faced ibis project that's been going on for about 5 years. And last year we started marking Avocets. So we have one of the largest databases on Avocets now. And we're going to be marking more this year. One of the things that I'm really super excited about was we were able to mark a small handful, but still Wilson's Phalaropes for the first time ever. we got a tag. This tag is doubly nice because it's satellite, so it'll transmit from pretty much anywhere. The accuracy isn't quite GPS, but that's the little tag that's sitting there on top of it. Little thing weighs 2 grams, and we were able to track birds all the way down south last fall. And then just because we might as well add a few more things to the bunch, we've added great blue herons, bitterns. We just marked 4 new bitterns today. And earlier this week, we got our first long-billed curlew, which has been our nemesis bird we've been trying to catch all winter. And we finally got it earlier this week. And just to make things even more complicated, we'll add everything else under the sun. Later this year, starting actually next week, we're going to be marking pelicans and cormorants up in Klamath to understand some of the predation on endangered suckers and other fish in the Klamath Basin. And the hope is by next year, we will be able to start marking eared grebes as part of the Saline Lakes IWAS initiative, in addition to expanding our work with some of these other species. So all of this is possible because the devices, our ability to get smaller devices on birds, better power management, so it makes sense to keep tracking them. You know, when we started 10 years ago, the smallest tag we could get was 20 to 25 grams. It communicated on the old 2G SMS network. And this was actually kind of a problem because when 2G went to 3G, every device that we had out failed overnight. And so we had about, I'm gonna guess, probably on the order of $100,000 worth of equipment that now only work on T-Mobile because they were the only ones that didn't upgrade their cell towers. And so some individuals were still working just fine if they happened to be sitting near a T-Mobile cell tower. But we lost a lot of individuals very quickly when that happened. And then the same thing happened again when we went from 3G to 4G a few years ago. If we ever do get a nationwide 5G network, it'll probably kill our project because one of the consequences of going up to these higher power, higher efficiency, you can transfer more information more quickly, but the consequence of that is that you have shorter range. And so it's easy to put up 5G towers in a city where you have all the infrastructure and power poles and everything else to put those on, but you're never going to get the range out in the wildlands where these species go. So I don't think we have to worry about that too much, but it's still one of my concerns out there. But over the course of this last 10 years, the magnitude, the size of these tags have shrunk by an order of magnitude. We now have a 2-gram tag that will communicate anywhere in the world at any point in time, as long as the appropriate satellites are overhead. Now, the accuracy of the locations isn't quite GPS, but if you have a species that's moving like Phalaropes from the Klamath Basin to Argentina, you don't really need to have GPS quality to understand some of the things that you need to know.
So Cory,
yeah.
this is Larry. You must have lost just like an overwhelming majority of stats when that happened.
Yeah, I mean I mean the one thing about it, I guess, that I keep as my consolation is a lot of the devices in general will only last us usually about a year and a half. And that's a combination of device failure, which is actually pretty limited. But what happens more often is we got two primary causes why we no longer get data for a bird. 3 if you include device failure, but like I said, that's, I don't know, maybe 10% of them will end up failing. What usually happens is either the birds will go out of cell phone range. So a lot of our species go up into the Arctic, and they do really well all the way up into Edmonton. But once they cross into the boreal forest and they get out of cell phone range, there's really only a couple cell towers once you get out there. We're super fortunate. Last year, they installed a new tower in Bethel, Alaska. So now we're getting data from Western Alaska that we for years have never gotten. We had to wait for those tags to come back in the fall because they'll store the data. But so many of the individuals will end up dying up in the Arctic that we never get anything once they go up. So that's probably the primary cause why we don't get data. The other one is the device will get damaged, whether it's a predation event or harvest. You know, we do most of the species that we mark are ducks. We do get a fair amount of harvest, and every once in a while, one of them will catch a pellet or an eagle's beak or an owl's talon, or a coyote will just decide to play with it for 4 or 5 days in a row, and it comes back looking like a hunk of plastic that it's been chewed on. But yeah, we did lose a lot, and the unfortunate thing is that the people that make these tags really have no control over that. They really don't have any ability to dictate what AT&T is going to do. You know, and you know, we're kind of limited in sort of that respect, but these tags have really improved. I'm really excited this year. We're finally getting these new 3-gram tags, 3.3 gram tags. This is going to just open up just about everything. There's only a handful of species now that we won't be able to get GPS quality data on with a 3-gram tag. So, and so what has this gotten us? Well, our project is one project. It's one of the bigger ones that's going on, but it's not the only one. We're actually cooperating with people from across the country on different things. And we have 13 main projects that we cooperate on and kind of all share data and work together on stuff. And in total, we have over 3,500 animals that have been marked since 2014 out of this. This is exponentially more than most studies have had in the past. Like a good study in the past would be 300. A great study would be 100. You know, to have this many individuals being able to provide information about habitat use and variability among individuals is really great. And among those, we have over 30 species marked now, and getting more. By the end of the year, that number of animals will be well over 4,000 just by what we're planning on doing. And we know of several other studies that are putting out 500, 600, 700 tags. And in total, we now have 3.1 million locations. And these locations spread from the Yucatan, where we had an ibis decide to go and play around in the jungle for the winter, all the way up to Wrangel Island, Russia, and Baffin Island. And you know, these animals really cover the entirety of North America. So pretty extensive work, and these are some of the groups that are you know, being kind enough to donate their data to our effort, and that we can leverage to understanding how the Great Basin ecosystem functions for migratory birds. These are just a fraction of the folks that are working on stuff, but these are some of the main ones that we've been working with for years. And so what has our work really been about? Well, it's primarily been on this local and regional management of whether the habitat or the species, trying to get to better decisions and better understanding of cause and effect when somebody is doing habitat management. Are the animals actually responding? It's really kind of sort of a sad state of affairs when you sit back and think about it. Most of the big dollar conservation projects, the big, you know, $100 million projects, their success criteria is whether or not they moved the dirt, not whether or not the animals responded to the dirt being moved. And there's really good reasons for that. It's really hard to get that information. Sometimes that information isn't available for 5, 6, 7, 10, 20 years, depending on how long it takes for habitat to really develop and come back in. But it also really points out that we have a big blind spot. We do a lot of things. We do a lot of things that we think are good. We evaluate them as successes, but a lot of times those successes might be a bit premature. We had the number, I forgot the numbers off the top of my head, but there's been something like $700 million spent by the Wildlife Conservation Board in California. They have, I don't know, 400 or 500 projects that they've worked on since the 50s. And they only can get to every project that they have active now once every 5 years, just to see what the condition of that is. And that doesn't even include any real assessment of whether or not it's being effective. And that's the kind of stuff that we're trying to develop a system to feed in so that we can actually understand what's working and what's not based off of what the animals are telling us. We also do a lot of disease work. And this is in the news every day right now. It's occupied my boss for 48 of the last 24 hours. He's really been slammed with bird flu in particular stuff, but we do a lot of work across the country understanding how waterfowl transmit and carry bird flu. We published a paper 2 or 3 years ago now that said, hey, you know, a lot of our species go to dairies and feedlots and occupy the ponds that are associated with those. That's a potential risk of HPAI transfer. And never expecting that 2 years later we would be finding avian influenza virus in milk all across the country. So it really shows the value, and even when you don't expect it, odd findings end up having a way of turning around and becoming a lot more relevant later. We also have this great project with folks out of Yale that we're looking at the impact of COVID and lockdowns on species space use and how they both physically moved throughout the environment and how they changed the variability of the places that they would want to be, whether people were active or not active. So really interesting study that should be coming out soon.
So I have a question, Cory. So are the waterfowl getting the avian flu from the cattle?
No, not likely. The cattle are more likely getting it from the waterfowl. Waterfowl have been a known carrier of bird flu for since the first outbreak in like 2004, I believe it was. But what's really unusual about the outbreak over the last 2.5 years is the disease was really primarily a waterfowl disease, ducks and geese, and it would occasionally infect people. And once in a while, you might find something else that died that maybe tested positive, but it was really unusual. The last 2 years, we've seen a really dramatic shift in the number of species and the types of species that are being infected. Polar bears are getting it. Foxes, seals, whales, I think, are getting it now. Seabirds that were thought to be, so far removed from where the waterfowl were that they weren't at risk, really took it on the chin last year. Some really big die-offs and things like northern gannets and stuff. And so the one thing that's generally speaking kind of nice about waterfowl is they're not usually cross-equatorial migrants. But when it started infecting all of these other species, it really rapidly went to South America. And it's not that it couldn't have been a blue-winged teal that jumped down to Colombia or something, didn't bring it down, but just the ability to being able to get a lot more species, Swainson's hawks and everything else carrying it down, just seem to really exacerbate the spread over the last couple of years. So it's still super surprising to me that that things like cattle are getting it. But it's not super surprising to me that they're getting exposed, because our habitat management also tends to result in a lot of co-occurrence of farm animals and waterfowl. So, yeah, we're also looking at sort of this same sort of topic with condors. You know, condors really had a hard time last year, particularly the Four Corners, Arizona population. The California side of California condors tended to do okay. I don't think we found avian influenza in them yet, but we had significant mortality event in Arizona, and we're trying to understand what the dynamics of bird movement and cross contamination from waterfowl or other migrating species into condors might have been. And that feeds into kind of what a lot of our main work is migration, understanding migration, the drivers, the causes, what's important when. And it's not our office that's doing a lot of this stuff directly, but we are contributing to a lot. This effort, I'll give you guys a few minutes to try and orient yourself to this map. It's a really hard one to wrap your head around when you first see it, but this is a polar view of North America, or of the Northern Hemisphere, and these globally distributed populations of greater white fence, and the different migration strategies that these populations have. So a species that is recognized around the world as being one species, and how different each population is. And this also feeds into some really more direct management stuff. We've looked at risk abatement at Superfund site, the Berkeley Pit, and how fall migration conditions can be associated with activities that might predispose them to landing at the pit, which is highly toxic and has been known in the past to kill thousands of snow geese. And then drought. Drought is really where most of our money has come from for the last several years, trying to figure out what the effects of drought are, how to manage drought, how to ameliorate the effects. This is the natural experiment that nobody ever wanted. The figure on the left is August ground cover aerial imagery of the Central Valley in 2022, and the figure on the right is a year after 2023, a more normal year. And all of that green that's on the right, that's not in the left, is rice that was not grown. And rice is pretty much without a doubt, hands down, the #1 food source for just about everything that wants to have its feet wet in California in the winter. 20 years ago, they were trying to plan conservation plan with the Central Valley joint venture, and they were putting in scenarios of how bad could things get, and they never got this bad. 50% of the rice in the state wasn't grown in 2022. 80%, 85% of the rice that was grown in normally the highest rice growing region wasn't grown. Wow. So overnight, 85% of your habitat went not just from rice to like fallow ground. Fallowing rice happens all the time. It's part of a natural rotation that agriculture has. It doesn't happen very often, but when water prices really go up, you'll see more rice fields fallowed. But even when they're fallowed, they're still prepped for fallowing, right? So you'll still have residual cover. You'll have good weedy stuff. Sometimes they'll put a cover crop down to kind of replenish things. In 2022, the decision to not allow water deliveries happened, I believe, at the beginning of April. So everybody had already prepped their field, or maybe it was May, everybody had already prepped their fields for planting and had plowed it over, and it was a moonscape of bare ground, not a weed in these fields. It was literally like excising 25% of the Central Valley for the summer. And you can see there's a couple little spots in here where people had really deep wells and a lot of money, and they were able to still grow stuff. And a lot of these spots got were able to be enrolled in incentive programs to provide habitat during, sorry, I was pointing these ones here on my other screen. And they got incentive programs to provide water for migrating birds early in the season and stuff, because everybody knew it was going to be a really bad year. And that's a lot of what we're working on right now, is trying to understand how effective were those? Where did it work? Where did it not work? What sort of actual implementation did the best? And so that's a big part of our work this year, is getting to final quantification of that.
I'm sorry, did you say that was last year?
It was we got the money to start the work in October of 2022. And so this sort of the drought was at its worst in 2022. We were able to get tags out and start marking birds in October of 2022, but unfortunately our funding from all of our previous work had almost dried up by then. Like, we had a couple tags that were still active, but we were really limping along and kind of looking for the next thing when the state drought money was able to finally come through. So we don't really have much from 2021 to compare with. So we had to compare with 2023. And it's kind of one of those things where when we started, as we were planning, it was just an absolute, like, nobody could believe how bad things were. And then, you know, whatever it was, December 15th came around and the skies opened up and it didn't stop raining for 4 months. And all of a sudden everything shifted. You know, and we went from the least amount of water, the least amount of habitat, the least amount of everything, the absolute worst conditions. And in a matter of weeks, we went to refilling an ancient lake that hasn't had water in it for 80 years. You know, it's really like the whipsaw that everybody's still holding their neck from that. But that probably really saved a lot of our wetland dependent species. You know, the trajectory that we were on just from October through the first couple of weeks of December was really not looking good for how things were going to end up for a lot of those things. And I think a lot of them still didn't do well. You know, despite everything kind of turning around in December and January, we had almost no waterfowl reproduction. Very, very low, like in the lowest 10% of waterfowl production that we've seen. Even though conditions were good by the time breeding season got here. It just took that a whole year to recover, to get back. And now this year things look great. You know, about as good as we've seen in 20 years. So anyway, not talking a lot about the Great Basin yet. Sorry about that. I will get there, I swear. Habitat use and selection is a big part, and really trying to get down to what's specific when birds need it. So nesting habitat, brooding habitat, molting is a really big one, and is really what Northern California, Sonic, Northern Nevada really excels at providing, because of the dynamics of water and land use change within the year in the valley. The wetlands in the Great Basin are really key for a lot of those late summer life history stages. And our birds really show that, that I'll get to. Although it's often not the best source of information for demographics, we do try and inform things from radio telemetry. We know that putting a radio on a bird affects it. We don't really want to use our survival rates as the best source of survival information, but it does usually provide a good lower bound of what we can expect, and allows us to understand a lot of the causes and consequences of mortality too. Things like moving. I work with rails in the Bay too, and they're really kind of funny because they're super territorial. They don't want to move. They don't like moving, and the moment they do, they die. Their survival probability is so low when they go to a new place. And we see the same thing with migrating birds. Cinnamon teal. The rate that a cinnamon teal will die when it moves to a new pond is probably 4 or 5 times higher than if it's moving around where it normally wants to be. And that has a lot of implication for species when they migrate. And it's just a matter, it's probably a normal, like it's, if you jump into a new pond, you don't know that that's where the eagle hangs out or where the fox lives. We also provide a lot of data to something called the Arctic Animal Movement Archive. This is a global effort to understand habitat use and movements by Arctic animals, species that usually can't be studied the way we normally study stuff. So we've provided probably still the most locations and the most individuals of any taxa to this effort. And this is our Aims for Wildlife. That's really our flagship stuff that we're doing right now. And this is what I was talking about before. It's really focused on conservation delivery and providing information regardless of the scale, right? So this could be, it was really originally developed to provide information to local resource like refuge managers, state wildlife area managers, but it scales up to understanding things like conservation gaps and regional conservation needs. And enables one refuge to coordinate with another refuge when drought is happening, and so that as a network of sites, they can offer what's needed when it's needed, even though one site isn't able to do it year round. And then we also are trying to develop this out to be able for folks to ask and answer even more complex questions, to be able to design better experiments, to design better conservation programs as well. So what do we see out of the birds that we mark? Well, sorry that this is going to jump around a little bit, but you can kind of get a sense of this. These are all the different dabbling ducks that we've marked. And what you see is that there's some commonalities, but there's also a lot of differences. And some of these differences are flyway differences. What happens in the Pacific flyway might be a little different, but really for species that are all in the same place at the same time, almost every one of these birds was marked within 100 miles of each other in the Central Valley of California. They all really do something different when they leave. And that just means that our scope of conservation delivery really needs to be wide scale if we want to keep everything that's working together. And a good example of this might be mallards, right? So mallards nationwide are monitored using a series of surveys that are primarily focused on the prairie pothole region up in here where mallards generally breed. And if you look at mallards that are marked in the Central and Mississippi flyway, they might have some localized movements, like this is where these birds were mostly marked, so it's not surprising that you have this little hot spot here. But when they leave, they're pretty widely dispersed and remarkably evenly dispersed. You get a few birds that kind of go off into weird spots, but they're very sort of evenly distributed across the range that they cover. Whereas if you look at our West Coast mallards, these guys have 2 spots by and large. They have the Central Valley and they have the Klamath Basin and a few other spots in Northern California. And yet this species is still, until recently, has still been managed as though it's one big group. Well, these birds basically don't migrate unless you want to consider going the 100 miles from Sac Refuge to Klamath migrating. They really operate very differently. And a lot of the species that we have in California overwinter, right? Maybe not in large numbers, but mallards certainly do. So do cinnamon teal, so do gadwall. And those are three of the biggest species that are here in the winter as well. Widgeon, of course, migrate, and pintail migrate. Pintail are incredibly important in California, or California is incredibly important to pintail. But unlike virtually anywhere else in the country, California and Sonic need to provide both wintering habitat, which has been the focus for the last 25 years, and breeding habitat, which until recently has kind of been assumed to always be there to the degree it was needed. And we're really starting to reassess that right now. That's a big focus of our work right now, is to understand what is the breeding capacity for populations, because we know that breeding mallards and breeding gadwall in particular are really dropping. And this really shows that just as well. This is just color coded by month, and you can see that all these birds are leaving. These movements out are movements down here are really in the winter, but that's not the case in here. It's really year-round occupancy over here in the Pacific coast. Very different sort of population dynamics than the rest of the country. Pintail are very different. Pintail are historically very focused in the prairie pothole region. They still are. That region extends all the way down into South Dakota. The birds that we're marking here in California tend to be located further north, but they're also going a lot into the boreal and into Alaska. And this is a strategy that seems to have changed over the last 20 years to some degree. We used to get a lot of birds that would go from the valley to Klamath Basin, and then it would be about a split. About half of the birds would go up across the ocean to the Yukon-Kuskokwim Delta in western Alaska, and the rest would go into the northern Great Basin or into the Canadian prairies. But what we're seeing now is almost everybody's going into the Canadian prairies, and rather than staying in the prairie pothole region, a lot of those are continuing north. And very remarkably few, I don't want to say very few, but a surprising number of those birds are not making it back. And we have no idea why. It could be transmitter issues, but something seems to be happening to me here in the Arctic that's a big black box, because these birds are also leaving cell range. And we don't know whether they're dying on the way up, whether they're breeding and not making it back. It's a big unknown. It's a big focus that we need to look at. And if I look at just sort of the breeding months, you can kind of see that there's still a fair amount of use down here as we get some late departures, and they're pretty well spread out throughout the prairie potholes, at least the northern portion of the prairie potholes. But there's all this use up in here in the Arctic, and this has still been pretty much a black box. We need to understand this a lot more if we're going to understand the trajectory of this species in the future. Geese are kind of unique. I love that we're working with geese now. They're with the exception of the snow geese, they're kind of all on autopilot. These orange ones over here are Canada geese. Canada geese they're robots. They go straight north, straight south, no matter where you mark them. Really kind of cool. All of these red ones are the white-fronted geese. There are ocean-going geese. We've actually recorded these birds taking a whole week to go from the coast to Alaska and just sitting on the ocean and floating around. Like, nobody knew that they would sit on the ocean for a day at a time. But they will routinely as they go across. We've seen a snow goose do that once, but when we went back and looked at the weather conditions when we did it, it was blowing like 60 miles an hour. It had 20-foot waves. And that bird sat on the ocean through that for 3 days and then managed to make it over to Ketchikan and disappeared from there. Really shows kind of the extreme conditions that these birds can experience when they're moving through. And one of the really surprising things to us is all this green in here is the lesser snow geese. And what we really see is that there's really a wide range of movements. We used to think these birds are colony nesters. So they're going back to the same spot. There's a colony here, there's a colony here, there's a big one on Wrangell, there's a big one on Banks. And the birds are still using those. But what we're seeing is that from year to year, they're switching between these colonies a lot more than what we thought. And sometimes they're even switching all the way over to a different managed population. You know, this bird over here on Wrangell went to a colony and bred, but not successfully, but actually had a nest in a totally different part of the Arctic than where it was marked. Another thing that snow geese are telling us, and this kind of ties into the bird flu stuff I was talking about before, is this is our current distribution of marked snow geese right now. And what you'll see is just about everybody is up here around Edmonton or already headed into the Arctic. We've got a few little stragglers back here, but we've still got this dot back here in the valley. This dot is actually 3 dots. We have 3 birds in the middle of May still sitting on Sacramento National Wildlife Refuge. Now, any other year, we would have thought that was strange, but last year we had about 300 birds that were still on Sac Refuge in June. And by the middle of July, they were all gone. And we thought that they had all either left or got eaten or whatever. But recently we're hearing that actually a bunch of them went further south to the San Joaquin Valley. This year, it's not 300. The last estimate we have is 14,000. 14,000 snow geese in June sitting on Sac Refuge. And when we looked into this last year, or when we were just trying to mark birds there last year, we were marking birds. A lot of them were there really late, and we collected a bunch of birds for bird flu. And when they did necropsies on those birds, birds that were positive for bird flu, they actually found that these birds actually had like lesions on their brain. Like bird flu is bad enough that it can cause gross pathologies. And so more than enough to change something like migratory behavior, prevent migration, prevent whatever else. So not sure what's going to happen with these 14,000 birds that are down here right now. Several of them will probably still leave, but definitely a change. Nobody has ever talked about seeing this many snow geese in the Central Valley at this point in the year. And the only way that we know this at how unusual that is by having this large-scale marking and long-term marking effort. If we didn't have it, this would be a kind of a big unknown. Cranes are a fun one. We marked these for the first time this year, so we don't have a whole lot of data. Years past, we did some work with some satellite telemetry and a collaborator at Oregon State. So we kind of knew that we've had this connection up here to Homer. But what's cool is even though we marked all of these birds in the same spot, we're getting some of these Great Basin breeding, likely Great Basin breeding sandhill cranes as well. So really nice marking birds that are wintering in the same area, all exposed to the same things, have different migration strategies and distribution. So it's going to be really cool to learn more about that species. A little bit about our water birds. Our ibis and avocets. Our ibis data set is just outstanding. I can't believe that we've been able to coordinate with Fish and Wildlife Service on this. I think there's 120 ibis now that we've had marked and throughout the West at several different spots. And what we're learning a little bit is that both ibis and avocet to a lesser degree really don't have the same sort of phylopatry that waterfowl do. They have some for sure. They will definitely go back, often to where they were before, but not to the same degree that waterfowl do. And they really spread out a lot. And also these species, by and large, are going down into Mexico too. So we've got two very different sort of conservation landscapes to support these birds over the winter. Really interesting. These are going to be some of the species that are going to tell us the most about potential connectivity across the Great Basin, habitat use patterns, and it's important to know the degree to which a species is phylopatric, especially in an environment that has both anthropogenic and natural variability from year to year. If you are strongly phylopatric, but there's a decent chance that you're not going to have water next year, that's not a very good strategy. If you move around an awful lot, and your habitat is variable, then you have a decent chance of being able to find something that's going to work. So I'm really excited that we have these data in here. And apparently we now have international Avocets too. This bird was marked actually here in California as a test case and spent last summer in Malheur, kind of moved around the Oregon Lakes area. And this year went back to Malheur, but Malheur has so much water that they actually don't have great shorebird habitat right now. The water's a little too deep for a lot of them. So this bird decided, well, why not? I'll give Alberta a try. So last week, this bird kept going north. This is the fun data. This is the Phalarope. So this isn't GPS, so it's on a little different type of map. But these birds were all marked in Klamath, not known to be a hotspot of Wilson's Phalaropes, but there's several that are there. Were pretty easy actually for us to capture up there. We marked 5. We only got really good tracks for 3 of them. One never transmitted at all, and one the battery was not recharging. But we got these good tracks for 3, and you get to see some really interesting sort of migration strategies. All of these birds kind of came down at about the same time, and they all came down shortly or midterm after what we call the hurricane, that hurricane that came through last year on the same day that they had the earthquake in San Diego. And you know, a Pacific Coast hurricane is a strange enough event. Earthquake on top of it makes a nice timestamp for everything. And what was really interesting is this bird that kind of came down here to Baja and then up back to the Colorado River was the first bird to come down after that. Came down 2 days after the hurricane came through, still probably passing through the tail end of the winds and everything as it came down. And this spot here in the middle of Baja where it stopped at was entirely dry, not a drop of water before the hurricane, and was a big playa that filled up with water when the hurricane came through, and that bird found it within 2 days of it appearing. I don't know what food resource would actually have been in that water after only 2 days, but the bird spent a couple days there and then backtracked up to the Colorado River, and looks like it probably died in the Colorado River. My guess is that being a small bird, having this pathway and then spending 2 days in fresh habitat, probably wasn't able to get the food resources that it needed, would be my guess. This individual that went more interior, we thought the same thing had happened. It was migrating down through and all of a sudden started transmitting from the middle of the Mojave, and we're like, oh no. That's not a good spot to be if you're a water bird. Turns out this little cluster of points that's right in here is a big valley where there's an army base. That army base is built there because it's nice flat land and they have a big runway. And that runway was under about 3 feet of water because of that hurricane. So these ephemeral, you know, once in a decade sort of habitats, these birds found and used very, very heavily for long periods of time when they appeared. Really goes to show how quickly animals can adjust to changing conditions. And that bird went down to Mexico City and was down there for actually about 2 months before we lost contact with it. So I've talked a little bit about what kind of each of the species, each of the groups do, but there's still a lot of sort of variability among the species, even in kind of these sort of smaller ranges. So the sort of northern part of the Great Basin, you can see that there are species that are appearing where other species tend not to, like the geese over here by Nampa and Boise in Ontario. A real hotspot for birds is their staging to go over the Rocky Mountains. They don't all stop there. Several of them go to Malheur, but we get almost no use in the Klamath Basin anymore by our geese. The white fronts will come over here a bit more, but not the snows, not the way they used to, 30, 40 years ago. And we also have spots like Lake Abert that are really principally only used by the waterbirds. Under the right conditions, you can get really good habitat in there for some other birds, but it's really the avocets that are comprising a lot of this stuff. And when you zoom in, you can see that even more. So Summer Lake has, we mark all of our Tule white-fronted geese up here, so there's a really high abundance of yellow in this spot. But you can see that where the geese are and where the ducks are don't always overlap very well. Where the waterbirds are, same thing. And this goes down even in micro scales. And this is really important for us to understand in the context of this Saline Lakes IWAS, because the one thing that's connecting all of this stuff is water. Every one of these systems has a certain amount of water that's coming in. People, nature, habitats are all using that water. And then there's a certain amount of water that's making it to the next step. And the saline lakes themselves are that final step. The only place that water can go there is a little bit of it will go into the ground, most of it will evaporate. And so the dynamics that keep that water in, the fluctuation throughout the year, the fluctuation from year to year, are all things that affect habitat quality in various different ways. I don't even necessarily want to say in good ways or bad ways, because what's good for one species is going to be bad for another. And so there's almost always going to be some sort of trade-off in here. And really the important part of the hard part, not the important part, but the hard part of quantifying this system is really figuring out what knobs to turn that will benefit this species and that species in this way, so that when we're evaluating our options later, we have that sort of mechanistic understanding of the system. And these things can be really close. Like if you're zoomed out just a little bit from this, it all looks like it's one thing. But when you really look in at how the animals are using it, you really can see that it's at least two things, maybe three things. If you bring this in if you bring time into this as well, you can see that it's actually maybe a couple other things going on here as well. And that's, this is a good example of that. This is all Avocet data at Lake Abert, and it's color-coded by month. And really what this is showing is how fast that shoreline receded last year. These locations up in here, an Avocet can only reach water that's so deep. And so in June, it could forage in this area and a little bit along the edge. In July, it had to go a little bit further in. By August, it was completely in a new spot of the lake. And so if we're trying to understand the system and just taking one snapshot throughout the summer, we're really going to miss how much foraging habitat there is. And what we really want to be able to understand going forward is this extent right here is a lot smaller than the same extent than the amount of area used in October. Did it have to be this way? Or could it be smaller because resources were more abundant and they have to cover more ground later in the season? We don't really understand that dynamic. Like this isn't necessarily bigger for an important reason, but it's also not the same, so it might be an important reason. And implicit in the saline lakes, in our approach to understanding the saline lakes ecosystem, is that all of these different basins, although hydrologically they might be functionally distinct from each other, in terms of what they provide to these species, they're all really connected. You know, we marked birds at 3 spots last year: Great Salt Lake, Oregon lakes, which was really, it was Malheur, Albert, and Summer Lake, or Abert and Summer Lake. And we had 2 birds that were marked in California. There are 40 lakes on the saline lakes list. 20 lakes on the saline lakes list. Those birds hit, like, I think 15 of those. In 1 year, 40 birds hit over half of the regions that we were thinking might be important in the system, that we were directed to study. I wouldn't have expected it to have been that extensive. Now, a lot of the use wasn't high. We had a little bit of use of Walker Lake, but it was just 1 bird for a couple days. Not the best Avocet habitat because it's a very steep-sided lake. But up at the front, bird did use it. Move on. By contrast, Owens Lake, we've had, I think 4 individuals have used Owens Lake, probably the most remote lake of any of the ones based off of where we mark birds. And we've had 1 bird that stayed there all winter long. So we have now almost a 8-month window into what does that lake provide and how does that change throughout the year. And this is a big change from what we used to do. This is the old banding data for a lot of the shorebird species. And what we used to get from marking, still a hugely valuable exercise, but all we really used to get was a starting point and an ending point, particularly for the waterfowl, because usually the ending was a little more permanent than it was when we banned shorebirds. But we really didn't get too much more than that. And now we're really able to understand these connections much more concretely using this information. So this was an awful lot of data and pictures and thoughts and concepts. I do have some more pictures of funny birds with tags on them. This is Andrea Mott, who probably put on more tags than anybody that we've worked with in the last 10 years. And she hates seeing herself in presentations. So I put her in whenever I can, just to needle her a little bit. And this is one of my funnest ones. Like, this is why I do this work, just to see the impossible. This camera was actually set up so that we could monitor whether or not we were having use of it at a spot that we wanted to nest. And it had a motion sense on there. And this was the very, like, maybe in the first 8 months that we were working. And we get this once in a million shot of a golden eagle going after a snow goose. And it just goes to show how clueless geese are, that golden eagle is already 8 feet past all the other snow geese, and they barely even have their heads up taking a look at it.
Do you think that that's because they don't see golden eagles very often?
In this spot, they probably see a lot. This is on Sacramento National Wildlife Refuge,
Yeah.
and I think our record is in the 1.5 miles that we drive to our capture spot. I think the record is still like 8 juvenile golden eagles in that 1.5 miles. So there's a lot in this particular spot. I think this is just eagles don't need to go after many geese, and so they don't go after them that often, you know. And there's so many geese out there that I think I don't really know, but I think the eagles probably have a good strategy. There's a nice levee over here on this side, and my guess is it's kind of like what we see with peregrines. They'll stoop when they can stoop, but when they don't, they hide and they'll fly level and try and stay hidden almost more like a goshawk. And I think that's what this eagle is doing, is it was staying low behind the levee, and these birds
so-
were all facing the wind and just never saw it coming.
Yeah, because when we see bald eagles flying over, they fly over and 3,000 geese fly up,
Yeah.
and circle around and come back, and it looks like the bald eagle's just having fun.
Yeah. Yeah, and I think that's the big difference between an eagle hunting and an eagle playing.
Right.
Yeah, I've seen, my favorite is the Cooper's hawks, the Cooper's hawks and band-tailed pigeons. The Cooper's hawks will totally change how they fly when they're hunting band-tailed pigeons, and they look just like a pigeon coming in. And I used to count them for doing the population surveys, and it'd be 1, 2, 3, 4, 5, 8 pigeons, 10 pigeons, whatever there, and I'd see one out of the corner and be like, okay, here comes another one, and all of a sudden at the last moment, all the pigeons would scatter. And I realized that last pigeon I counted wasn't a pigeon, it was a Cooper's hawk.
Yeah, they're about the same size, right?
Yeah, they are. It's really amazing that they would even try to go after a pigeon, but they do a lot. They're not usually very successful, but I have seen them catch pigeons by surprise. But it's whenever I see them when they're not hunting pigeons, they look like any normal accipiter that's flying around. But when they come in like pigeons, they'll lock their wings back and they'll fold, and they'll do that sort of pigeon sort of,
That's hilarious.
it's really pretty funny. So that's all I have. More than happy to have questions. I have data here. I don't know what time it is. I've been talking for a long time. I apologize for that. I get excited about these. So
Yeah, I wouldn't apologize for that. That was amazing. That's a lot of information.
and there's so much more to learn. I mean, that's really where we're at now, is sort of this twofold tack of, one, we're trying to sort of put ourselves out of a job. That's what Ames is really designed to do, is to get the researchers out of the way, because there's so many people that need to have this type of information and understand what they're doing at their refuge, their property, their whatever. And we can't know the things that they know to make that decisions. They're smart enough to understand what's working and what's not. They just need to have the data delivered in a way that they can do that. And if they have to work with us to write a paper to get something maybe in 3 years, that's just not a very effective way to do this. So what we're trying to do is get the researchers out of the way, make the tools so that they can understand how this stuff is working. And at the same time, that frees us up to do a lot of the real basic science that still isn't done for a lot of these species, and really focus on understanding the prevailing problems that we have, like the Saline Lakes Initiative. If you only have so much water and you only have so much land, and you have to find a way to deal with 20% less water, there's a lot of different levers that you can pull. It's not really up to me to say what your desired outcome should be, but it is sort of my job as the federal scientist to say, but if you choose to go this way, this is going to be the effect. And if you choose to go this way, this is going to be the effect. Like I was said early on, is any decision that we make with water in the West is going to pick winners and losers. There's no other way to deal with it. It's a limited resource, and it's always going to be. Now, there's probably a lot of things that we can do that really minimize the losers, and a lot of things that we can do that really have added value to the winners, but we don't really know what those are yet. So that's in when I'm the most optimistic about the government doing a good job, being the one in the government, that's what I think we're working towards. So
That is
Cory,
somebody-
this is Bruce Webb. On the screen, I'm Mom,
okay.
because this is my
Hi,
wife's
Mom.
computer. I'm stumped by the technology with the records that you're getting, and I heard reference to availability of cell towers, and as it goes from 3G to 4G and et cetera. How are you getting those records from North Siberia, for Pete's sake? Are those bouncing off of a satellite?
So the tags will all store data if there is no cell tower. So as long as they eventually come back in, they'll usually offload. However, there are a few towns up there on the Siberian coast that do have cell towers. There's like 2 spots where if the birds happen to go by at the right time, they're only trying to transmit up there once every 4 days. So,
But if there isn't a cell tower close by, first of all, I'm amazed that there's a cell tower that you guys can actually connect to in
Yeah.
Russia, for gosh sakes.
Mhm.
But second, if there isn't, how does the device know where it is at the time? Is it bouncing its location off the satellite everywhere it goes?
Yeah, so there's 2 main components in each one of these tags. One of them is a cellular modem that just transmits data out, but there's also a GPS receiver. And so that receiver works whether there's cell connection or not. It's just like having a Garmin in your hand.
I see.
Okay, it'll work anywhere. And so unless it will work anywhere. But if you have certain types of radio interference, or if you're flying over certain military bases, you will not get your GPS for very clear reasons. But generally speaking, that's not an issue. And so as long as there's enough, the really big issue that we have in the Arctic is it's so cloudy that it can be hard to recharge.
Okay.
One other question. On the screen, you had a bunch of references of outfits that you're coordinating with, and I didn't see Oregon DFW.
Yes, and that is not because we don't coordinate with them. They are probably except for California State where we're based, they're probably the biggest resource for land access and stuff. Those were the folks that have either bought transmitters or deployed transmitters for us.
I see.
And that's probably not fair either, because I know Marty St. Louis has put on tags that we have data for. So, but ODF&W hasn't specifically funded any of the data that we're currently ingesting. That's not to say that they don't have data that's available to us. Part of our system is to find all of these different data sets, quality control them so that we know that we can make appropriate inference from them, and then deliver it. And that's really kind of a needle in a haystack. Despite there being so much data that's out there, getting access to that data has been really tough. So that's where we spend a lot of our effort.
Thanks.
Sure.
So with all this new technology, do you feel like it's the golden age of information on migration and birding birds?
Well, in some ways, yes. In other ways, it's like, oh, we have so much more left to do. Some of the bigger questions that we have now are things like plovers and phalaropes, which, I mean, we've been able to tag phalaropes, but those tags are 5 times as expensive as the other ones. And so we're not going to be doing that very often at large scale. There's a newer technology called MOTUS. It's actually been around for a long time, but but it's really gathering steam on the West Coast. It's been developed in Europe, and then the Atlantic has had it, and it's really growing out here a lot. And the nice thing about those is they're super small tags. They can be less than a gram. They can be solar. They can last for a really long time, but they're radio. And so you need to have antennas out in a lot of spots in order to hear them. And they don't give you GPS. They just tell you whether or not that antenna heard it. So you can get kind of a neighborhood. You can kind of know more or less where it's at, but you're not going to get that really fine scale stuff. But for things like migration, that can still be important to know whether it's at this saline lake or that saline lake. You can get that. And one of the things that we're doing this year with the pelicans is the tag that we're putting on those is actually has one of those receivers built into the tag. So the pelican is going to get a GPS location and send us that data. It's also going to tell us whether any of those MOTUS tags are around it as well. So it's like a mobile MOTUS station. And it's nice because pelicans can basically carry a brick. So we can put that on there. So we're really hopeful that that will work. We want to do a little bit more sort of testing of it. We want to do some real good comparisons with birds that have both GPS and MOTUS on the same time, so that we can understand how frequently is that MOTUS tag really connecting. So there's a lot to learn about it, but that's pretty exciting, because that's something that is kind of on one hand really the most collaborative effort, because every tower is pretty much managed by somebody else. You know, every tower kind of has their own patron that's worked on it, and everybody's working together to get the data off of it. So and they're not cheap. You know, it can be upwards of, you know, it can be as little as a few $100, upwards of $10,000 to operate one of those, depending on where it's at and how you want to build it, how you need to get the data off. So and they have these things all the way down to, you know, through South America. There's a report, I don't know if I believe it yet, but there's a report from one of the Phalaropes that they marked in Saskatchewan last year that it's been down in Colombia this winter. So it'll be cool as that rolls out.
We just had a huge influx of redneck Phalaropes here locally, something like 700 here in Redding. And then I went down to the Sacramento Wildlife Refuge. It was just last Saturday, and I must have seen 200 or 300.
Yeah, it's probably the right conditions, probably about the right time. I really wish those 3 Wilsons that had transmitted had kept going. I went down to Baja this year, and for my first trip ever, and I was blown away at how many Phalaropes, probably mostly rednecks, but how many Phalaropes were off the coast. I mean, 40, 50 miles off coast.
Oh, wow.
I mean, just thousands of them. I mean, individual, but individual everywhere. It was really, really amazing how many. I was out there fishing, so I just thought that they all looked like tuna bait, but yeah, there were a lot of birds down there. So I think under the right conditions, you know, and that's the route that our Wilsons, you know, they went through the Central Valley. Well, 2 of them went through the Central Valley to come down. So, you know, I think this year has been a weird year for migration in a lot of respects, but I think that these devices could really go a long way to things like the migration mappers and developing good migration alerts for folks to know when they're coming through.
That's really important stuff. All that data is so important.
Yeah, and you know, and it's amazing how much, you know, I mean, most of what I study is ducks, and the most common question that I get, at least from other ecologists, is, don't we already know everything about ducks? And it's really surprising how much we don't know.
Apparently not, if you're still making discoveries about mallards.
Yeah. Yeah, for sure.
Mhm.
Well, excellent, excellent presentation. Does anybody have any more questions for Cory? He pretty much covered a lot of stuff there. So I'm going to stop recording.